Hey, so welcome to the fifth video on data analysis. This is Ratankar Rao, and I will be doing data analysis video, which is on transformations. Okay, I share my screen. Right. Okay. So far in the previous four videos, what we have seen is that what we have seen is that we have looked at what are the different types of graphs, what do you mean by uncertainties, what do you mean by errors, what are systematic and random errors, and we looked at how to calculate uncertainties in equations. We've seen all these things. Okay, and in the previous video, we have seen about significant figures also. Okay, how to use significant figures. The next part of it is transformations, which is very, very important. Okay, from your data analysis point of view. Right, different types of graphs. So earlier also we have seen different types of graphs, and here we are looking at from the equation point of view. The first type of graph is a linear graph which tells you y equal to mx plus b. Okay, where in the equation the dependent variable, that is your y-axis, is now dependent on the value of x in terms of like this. Then you have power graph wherein the equation can be written as y equal to ax to the power of c plus b. For example, the equation, I'll just give some values of it so it becomes clear for you which is better. So this equation, the graph for this one could be something like y is equal to 3x plus 1. This could be an equation here. And here what could be the equation? Here the equation could be y is equal to something like 3x square plus 1. I'll use the same coefficient. It'll be easy for you. Then here, okay, let me say y is equal to something like 4 by x squared, which is inverse square law. Okay, and then here, so this could be y is equal to something like 7 root x, right? So you can get something like this. And here y equal to a into 1 by x. Where do you see this? This you observe it in potential, right? gmm by r, kq by r, right? So they use it. So let us say y is equal to something like 3 by x over here. Okay, so these are different types of graphs that we have. Let us move on to further ones. Now linearizing complex functions. Okay, so now what we do is let us take up a graph like s proportional to t and s is proportional to t square. For example, you can have s, let us take up graph like this. So when you say, let us take up an equation like s equal to half gt squared, and I ask you to plot a graph of s versus t. The s versus t, you get a curve like this over here. But if you square this, okay, and then you consider this as your variable and you plot s versus t square, what will happen? Now s is plotted on the y-axis, so this will be equal to y, and half g, I will take this as constant. I'll put this as m over here. And if I take t square as a variable x over here, then what do you get? You should ideally get a curve or a straight line which passes through the origin, right? Something like this. Now what have we done? We have linearized the actual curve. Okay, this was the actual pattern, but we have linearized. What do you mean by linearizing? Linearizing means we have converted this curve to a straight line, right? This is very, very important. Under what conditions can we convert it? Now, why is this useful? If you ask me this question, this is useful to estimate certain parameters. What are the parameters? Let us consider, for example, here this m. What is m here? Slope, which is equal to half g. By measuring the slope over here, you will be able to find out the value of g over here, acceleration due to gravity, right? So this is how linearizing will always help you out. In many places of your IBDP paper, you will be able to see linearizing condition. And they don't ask you to linearize, but somewhere they do the same task, but you need to understand how do you plot it. Okay, let me take up one more example. So like this, there are several complex functions available. For example, if I take, let me choose my different color of the pen, becomes clearer for you when I write. Okay. So if I take free fall, for example, s equal to half gt square, what should I do? I should consider this as my y and this as my t square is x. And thus if I plot y versus x, I will get a linearized one. So this I can do it. And then radioactive decay. So here I can't do it. Okay. Here I have to do it with ln n versus t. What I will do is let us consider all those functions, okay, which uses this distance versus time. Let me go to the next one. You see, this is called as linearizing by substitution, wherein what we do, we take that parameter which is occurring or which is making non-linearity, and then we substitute this value by x over here, right? So therefore here what do I get? I get s is equal to some m multiplied by x. So it is linearized. If you look at this here, this f is nothing but your dependent variable, x cube is nothing but your independent variable. So what I will do is I plot f versus x cube. So for this also I'll put this as m, and this I'll put this as some z over here. What is z here? Z is nothing but x cube here. Now in a similar way, if I look at this in case of Malus law, okay, in polarization, you see intensity I will call it as I over here, and this I naught is a constant. What is cos square theta? Theta varies, cos theta varies. But if I plot a graph of cos square theta versus I, then what will happen? This I naught multiplied by, let us say, cos square theta is equal to x. If the whole thing is considered x, I'll put this x. So you will get a straight line here. See? So in this case, what kind of curve you get? You will get a curve like this over here. You will get a curve like this. How are you linearizing it? You are linearizing it by substituting this value, right? Then next one, f is equal to mv square by r. Now which one will I take? I will take if v is not variable, r is a variable, or maybe so here f versus v square. If v square is a variable, then what I do is I will take f is equal to m by r will be the slope, right? And v square what will do? I'll put this as x over here. So as a result of it, okay, so once again a plot of x as f versus x will give rise to a straight line, right? And p equal to sigma t power 4, which is a Stefan-Boltzmann law. So here you see, you plot a graph of this is your p, which is nothing but your y, and sig t power 4. If I take it as x, I'll once again get this p is equal to mx, right? So the interest here is how much ever possible, try to plot the graph in the form of y is equal to mx plus c. This is what we need to do. Okay. So in a similar way, if you plot a graph of f versus r in this gravitational rule, then you see f is equal to gmm will be capital M, and 1 by r square will be your x over here, right? So like this, you are able to see how I can linearize the curved paths over here. This is by linearizing by substitution. But only these kinds of functions where you are able to break up the variable and then attribute it to a linear function by substitution is possible. Not every variable. Now let me go to the next one. Linearizing by transformation. Now this will take a transformation. What kind of transformation? Let us say I have, let me use a different pen, blackboard, so I need to use a white pen here. Okay, a equal to a naught e to the power of minus gamma t. So what I will do is I'll write a equal to a naught e to the power of minus gamma t. Take ln on both the sides. When I do this, what will happen? Ln a is equal to ln a0 plus ln of e to the power of minus gamma t. So which should now be equal to ln a0 minus. So this is gamma t over here. Okay. So what I can do is I can write this as minus gamma t plus ln a0. Now this ln a0 is constant. I'll write as c, and this gamma minus gamma, I'll write this as my m here, and t is a variable. Put x here. Ln a, I'll put this as y here. So what have I got? I've got an equation which is y equal to mx plus c. So if I plot a graph of y versus x, I will definitely get a straight line. So therefore, though this is an exponentially decreasing function, which is a nonlinear function, initially, if you had plotted a graph of a versus t, you would have got a graph like this. Now, if I plot a graph using this way, that is, if I plot a graph of ln a versus t here, I made a transformation here, right? I converted a to ln a. Then what will I get? I will get a graph like this over here. So have I not converted this to straight line? We have done this over here, right? So how do you linearize? This is the question over here. They understand the concept over here. The concept is that how do you make a curved path a straight path? What is the advantage of it? The advantage of it is you will get sure shot one slope over here. Okay. When you get a slope over here, what is the slope here? The slope here gives you the value of gamma. If you are using this one, you will not get the value of gamma similar to this. Okay. So that's where you should be careful. Right. Let us move on to the next one. Linearizing by transformation, which is this. Another example is about charging of a capacitor. So we have V equal to V naught into, let me write down, V is equal to V naught into 1 minus e to the power of minus t divided by RC. I have an equation like this. So I need to, so when I plot this one, definitely I will get something like this way. Like this way. If I plot a graph of V versus t, I'll get a graph like this. But I want a straight line. How do I convert this into a straight line? That's the question here. Okay, don't say I will take up this point, I will take up this point, I'll draw a straight line. If I draw like this over here, this will not be a straight line. This is called as a chord of the curve. Okay, so I should not do this one here. right? This is incorrect. So what do I do here is that I have this one, first expand this. This should be equal to V naught minus V naught e to the power of minus t by RC. I get this here. Then what I will do is I will consider this V naught to be in this side, and this one I'll push it here. Okay, and this one I'll pull it here. So which will now be equal to, this negative side goes that side, it becomes V naught e to the power of minus t by RC should now be equal to V naught minus V. Okay, I have pulled this V this side and V naught e power minus t by RC that side. So let me take the logarithm of both of these. So when I take a logarithm, what do I get here? I get ln Vc V naught plus ln e to the power of minus t by RC is equal to ln of V naught minus V over here. Now ln V naught will be just same, ln V naught, and this will become minus t by RC is equal to ln of V naught minus V. I get. Now what I will do is, I want, this is also a constant, this is also a constant, right? So what I will do, I will take this as, I'll take this ln V naught to that side. I'll do minus t by RC is equal to ln of V naught minus V minus ln V naught, right? So this is ln A minus ln B. What should this be? This should be ln of 1 minus V by V naught is what I get over here, right? So this is equal to so much. So what I can now do is, I can now say, okay, I'll do one thing. I'll not do all these things. Not do all these things because it is complicating a lot. I'll take from here. I will say this V naught minus V is equal to Y. I'll take from here ln of V naught minus V as Y over here. Y over here. This should now be equal to ln V naught is C minus T by RC is nothing but M into X, right? Where T is nothing but X here and M is nothing but, let me write down the parameters. Your Y here should be equal to ln of V0 minus V, and then ln of, what is C here? C here is ln V0, and what is your M here? M here is nothing but 1 by RC. So now if I plot a graph of this Y versus X, I'll get like this. What is Y here? Y here is ln of V0 minus V, and this is your T. Then probably what do I get? I get minus mx plus c. So I will get a straight line like this. So whatever you had here, I have converted this into a straight line, right? What is the slope? Slope gives you 1 by RC, which was not possible for me using this, right? So thus you see, so you are able to convert it, a curved path into a straight line one, right? Let me look for one more transformation. Photoelectric effect. So this, hope you have studied this so far. So V is equal to H by E into F minus F naught. What is F here? Frequency. What is F naught? Threshold frequency. So what I will do is, I will write here as H by E into F minus H by E into F naught. See, F naught is a constant. H by E is a constant. H is Planck's constant. E is constant. So this is a constant. Minus H by E is a constant. Let me call this as M. And the F is a variable, X here. This should be equal to, what is V? V is the voltage. Put it Y here. So if you now convert, if you now plot a graph of this one, then what will happen? You will once again get a straight line like this over here, right? You will get a straight line like this. This will be your intercept, right? So in earlier cases, we had been looking only at the slopes. Now, intercept will also help you out to get some information. What is that information you get? You will get an information saying that C is equal to H by E into F naught. H is constant, E is constant. F naught you need to determine. What is F naught? F naught is nothing but threshold frequency. What is the minimum amount of frequency required for a ejection of a photoelectron? You can easily get it across, right? So measuring this value, you can get this value. Thus, the transformation helps us in doing these things. See, just a transformation is not useful. You should understand why are you doing the transformation? Where does it help you? Okay. Now, let us move on to the next one. So far we have been doing only with transformation. The next is about testing for a linear and a polynomial function. Which function is a linear function? Which function is a polynomial function? We need to know this. In a similar way, we can test it for which one is a logarithmic function, which one is an exponential function, which one is a power function, right? So these kinds of things are also very important. Tomorrow, when we start working on the problems, you will get to know where these tests are being important. Okay. Now here, if you have, what do you mean by linear proportionality test? Very, very, very important here. What do you mean by proportionality? Proportionality. Usually, if I give an equation like y is equal to 3x plus 1, 3x plus 1, do you think this is proportionality? This is not proportional. Okay. The reason is because when you say proportionality, for any change in value of x, there should be a corresponding change in value of y, first condition. The second condition is that for a value of x equal to 0, the value of y should be uniquely defined. Okay. For example, so it should pass through the origin. That's what is important to me. So if I plot a graph of x versus y for this one, you will get a y-intercept equal to plus 1 here. This should be the equation. This will be the equation. So what kind of equation is this? This is only a linear plot. But what do I need? When I say proportionality, then this line should pass through the origin like this. So therefore, this is not proportional. Y is not proportional to x over here. Okay. So thus you can say it is only a linear one. When x doubles, y should also double. When x halves, y should also halves. Okay. That is the condition for the proportionality. Here what happens? If x doubles, what will happen? The y will not get doubled, but will get doubled plus 1 over here. Right. So this is not proportional. The next one is y equal to kx power n, which is power law. If x is scaled by a, y should also be scaled by a factor of a power n. Okay. Now let us look at this here. See, this is a plot which is being given, table is being given over here. So s versus t, 1, 2, 3, I keep on increasing this. What is this equation? This is nothing but s equal to half gt square. S equal to half gt square. So this is a power equation that's been given. So as a result of it, when the value of t is increasing, your t square value is also increasing over here. Now let us take up, according to this rule, if x is scaled by a, let us say for example, this is your value of x. If x is scaled by a, which means what? If x is multiplied by twice, which means which value does it correspond to? It will correspond to 2 2s are 4. It will correspond to 2. That means what? Initially, if the value of t is equal to 0, and you are scaling this twice, if you are scaling this twice, which means what? It becomes t2 becomes 2 into 2, which is equal to 4 over here. Okay. Then what will happen? So this value, if x is scaled by a, then y should also be scaled by a factor of a power n. Your y value, what is y value? Half gt square you have, right? They should also be scaled by a factor of a power n, which means first time when t is equal to 2, you get the value of y1 to be equal to 19.6, right? 19.6. This is what is the answer you get here. 0, 1, 2 here. This is for 2. So you get this answer. Okay. Now, if I take t2 should be equal to 4, your y2 will now be equal to, for 4, what is the answer? For 4, you see, it is 78.4. 78.4 here. Now, therefore, if I divide one by the other, 78.4 divided by 19.6, what will the answer be? Let me use my calculator to get it correctly. Where is my calculator? Is here. So I get 78.4 divided by 19.6. When I do this, I get the answer as 4 over here. 4 over here, right? I get the answer as 4. So what does it tell you? See, you scaled this one by this much amount. This also scaled by, and you need the same as whatever is your final value here. So thus we come to know that this is the power equation. Okay. Now let me move on to the next one over here. Okay. So just a moment. Okay. So now let me continue with this. Is my screen shared? No. Okay. Just a minute. Okay. So in the previous slide, we have seen about how do you test for the linear and polynomial functions. Okay, now let us move on to the next one. So logarithmic functions. In a logarithmic function, what happens is, as the function is y equal to ln x, or you can also have y equal to log x. Anything is fine. As the x value increases by a constant factor, the increase in y gets smaller. What do you mean by that? See, for example, if you look at this here, x increases from 1 to 2. It's increasing by only 1 unit. How much is this increasing? 0.69. See here, as this increases, once again 1 unit. How much is this increasing? 0.7 to 1.1. How much is it? Which is around 0.4 here. So here it is only 0.4. Okay. So if you look at this, This is only around 1.1 to 1.39. How much is it? 0.3 over here. And here 1.4 to 1.61, 0.21 here, right? And here how much is it? 1.61 to 1.79, 0.18 here. See, even though the value of x keeps on increasing by 1 unit, the value of y does not increase like that. It keeps on reducing. The worst part is here. See, it increases by 1 unit here. It increases by 0.1 unit. So as you go beyond the values, then you see that the values does not increase. It comes to a saturation. So you get a curve like this. This will clearly explain you that this is a logarithmic function. Okay. See, the question here is that how do you understand which function can that curve belong to? Okay, this is very much useful in curve fitting. By taking up some few two or three points, you can easily understand, okay, which curve or which function does it curve belong to. Okay, so for example, if this curve is given to you and you want to find whether this could be an exponentially rising curve or could it be a logarithmic curve, which curve can it fit easily? Okay, you ask this question, then what to do is take up the values, take up one or two values. Let us take up this value here. This is for x equal to 2. This is for x equal to 2. What could be the value of y be? Value of y could be 0.5, 0.7, 0.8 nearly, 0.75 nearly. Value of y could be 0.75 over here. For x equal to 2, I got 0.69 or 0.7. Okay, let me take like this. Then let me take up this value here. This value, what is the value of x here? This value, okay, let me take up x value equal to 4 here. X value equal to 4. Now what's the value of y here? Value of y is 1.4 over here. Okay, so what you can do is you can find out like this. Let me check my pen. Right, you can do like this over here. For x equal to 2, I'll write it down here. For x equal to 2, y was seen to be 0.75. I'm not looking at the table, I'm just looking at the graph. And for x equal to 4, the value of y was seen to be 1.4. 1.4. Let me take one more point. At x equal to 6, what's the value of y? Value of y is, what's the value of y here? This is the value of y, right? Value of y could be 1.75, 1.8, I think, 1.7, I think. So value of y is equal to 1.7. Now what I do is I take the differences between these two. Difference here is 2 here. Difference here is 2 here. Difference here 1.4 to minus 0.75 could be around 0.65 over here. Difference here is 0.3 over here. Right? Now you see it's reducing like anything. So which you can very clearly infer that this could be your logarithmic function. Okay? Fine. Next, let us go on to the next one, which is inverse relationships. Now, in the inverse relationship, when I have an equation like s is equal to 1 by t, what you need to do is, this is nothing but your y and this is your x over here. What you need to do is multiply this y and x over here and see that this product will always be equal to 1. Okay. If suppose if I have s is equal to 5 by t, what does it mean? That product of s into t should be equal to 5. Need not be 1 here because it depends on what is in the numerator. So it should be 5. Now let us take up this example. Okay, for every point it should be the same value. Okay, only then you call it as inversely proportional. Very important point. Make a note of this. Okay, so therefore now any curve like this will not give you inverse proportions. Okay, so only when this condition is met you can call this as inverse proportion. Now let us take up points like, for example, you have 2 and 0.5. Okay, 2 and 0.5. Let me take here. You have 2 comma 0.5, which is already been present. Product of these two should be equal to 1. You take this one here, 3.3 and 0.33, 3 and 0.33. What is this value? This is also equal to 1. Then 4 and 0.25, 4 comma 0.25, which is also equal to 1, right? So every tuple or every pair of points that I have shown over here, every pair of points will, the product of these two will definitely be equal to 1. Okay, only then you can say this plot is a plot of s versus 1 by t. You can try it out using your Python program or maybe your Matplotlib or maybe your Excel and try to plot a graph of something like y is equal to let us say minus 5x plus 1. If you do something like this, you get a similar curve, but this will not be inverse. It will not be inverse because the product of y into x will never be equal to a constant. Okay, will not be a constant. So this is not an inverse relationship. Okay, so for inverse relationship, this condition y into x equal to constant should always be present. Only then you can call it as an inverse one. Next, testing for square roots. Now in a square root happens is, what happens is you get a value of x, then you get a value of y from the graph. See, we always need to look from the graph point of view. Don't look at it from the equation point of view. From a graph point of view, so you get a value of x, get the value of y. If x increases by a factor of 4, y should double. If x increases 4 times, okay, let us take, I am taking this point over here, which is what x equal to, let me take some value, let me choose my pen properly. I'll take an yellow color pen. I think that'll be fine, right? Oh, I'm not able to write that also here. Then I think I can choose something like a blue color pen. Yeah, right. Okay. Is it right? I'm not able to see it. Oh my God. Okay, fine. Now let me choose values like x equal to 2 here, x equal to 2 here. When I say I'm going to increase it by a factor of 4, which means what? I'm going to write x equal to 4 times 2, which is equal to 8, which is equal to 8. Now, where is the point 8 here? I'm going to take up this point here, this point over here. Okay. Now, what does it say? Y should double. What is the y value for this one here? Y value for this one is 1.41. 1.41. Now, when you say you take up this point, it should be twice of this. Here, the answer should be 1.41 multiplied by 2. 2 2s are 2 4s are 2.82. See, incidentally, it is 2.83. So, thus you see, okay, this value is doubled, and this is the right test for it. Okay. So, take up 2 points on the graph and see whether this condition is possible. And definitely, okay, if it is possible, it is a square root function. Okay, so this is not an exponentially increasing function. See, curves which are very similar. Okay, so exponential function, exponentially increasing function, then you can have even square root function. Both of them appear to be similar, but you need to very clearly justify which one is which one. Right. Let us go to the next one. Testing for exponential functions. E to the power of ax and e to the power of minus ax. Now, how do we do this? So here, successive values of y increase by a constant ratio for constant increments in x, which means what? Let us say, for example, I'll take up two values. Well, let me take this value. X equal to 1, x equal to 1.25. So what is the value corresponding to it? So I get the value here on the graph as 100.43 and 182.9. See, this point has been plotted here only, 182.99. So what I will do is I'll take the ratio of these two. Okay, so I'll write 182.99 divided by 100.43, because the same difference, 101 to 1.25 is 0.25 difference. I'll take this value. So how much will I get this here? Let me do this here. So I will get the value, to take my calculator, I'll get the value 182.99 divided by 100.43. When I do this, I get the answer is 1.822. 1.822. Okay, one of them between these 2 points are taken, between these 2 points. Now let me take up these 2 points, 1.25 and 1.50. These 2 points, because these are also separated by the same distance. 1.25 and 1 is 1.25. 1.25 is 182.99. 1.50 is 333.43. Okay, 333.43. Again, I'll take the ratio, 333.43 divided by 182.99. Use the calculator once again. So I get 333.43 divided by 182.99. When I do this, I again get 1.822, right? So 1.822, which means what? Even the values of x are separated by the same distance. Get the values of y for such points, and then what you do is take the ratio, okay, adjacent points, and you see if they are constant, that means it's an exponentially rising function. You will not be able to say whether this is equal to 5 e power 3x. You cannot say that. Okay, but you will at least be able to say this is an exponentially rising function. The same thing applies even in case of an exponentially decreasing function. How do you arrive at here? So what you do is, let us take for example 0.25. What is the value corresponding to it? This is the value for 0.25, and for 0.50 this is the value. See, I have written the program in such a way that I get the plotting like this, but unfortunately Python made a mistake and we have got points at different locations. Okay, so now what I do is for 0.25, what's the value here? 2.74, and for 0.50 the value is 1.51. 1.51. Let us take the ratio of these two. 2.74 by 1.51. How much will this be? How much will this be? Let us take the calculator. 2.74 by 1.51. I get the answer as 1.814. So I get the answer as 1.814. 1.81 I'll take. Now let us take up this point here. So which is 1.51 divided by 0.83. 0.83, right? Which should now be, if I take this value, 1.51 divided by 0.83. So I get once again is 1.81, 1.81. Thus you observe that if I take the ratio of these 2 points, which are separated by equal intervals along the x-axis, and I get the same value, that means what I'm doing, it's an exponentially increasing or an exponentially decreasing curve. But once again, I'm telling you, I will not be able to infer what could be the equation from here. For this, you need to put it across to a software, and the software in turn will be able to do that. Okay. So what I have done is here is that I have taken one equation, generated points out of it, plotted a graph, wrote a program to plot a graph, and that's what I have got here. Okay. Now we have even tested for the exponential functions. Okay. See, the interest, once again, I'm telling you in all of them is that, okay, see, starting from here, okay, where is it? Testing for logarithmic functions, linear functions, everywhere. What is the interest here? The interest here is the use your input would be from a graph. You take a graph, take the points, from there you proceed. Okay, you're not taking from the equations. Now let me go on to the next one. If I have a quadratic equation, how do I know it's a quadratic? A quadratic equation will always represent a parabola. Okay, so when you take a parabola, now you see I have taken the origin or the vertex of the parabola at this point, which is 0. So what does it say? Values of y at points equidistant from the vertex should be equal. That is, y of x plus h equal to y of x minus h. Which means what? If I take, for example, at 0.50, at 0.50, whatever value of y I get, so what will be the value of y? I will get a value of y equal to 1.2 here. This is the first point, second point here. Second point is plotted here. Actually, it should have been plotted over here. Okay, so 1.2 should be a value here. And if I take the same value at x minus h here, you see, you get the same value 1.2 for this also. The first point is the second point. Second point here also you get this 1.2 over here. So this should be the same, which means what? When you have a parabola, draw a line horizontally like this. It will intersect both the parts over here. This will give you the values of x at 1.2 and 1 minus 2. Okay, so like this. So this is the test for the quadratic equation. Okay, you will get a symmetrical parabola. Then you see it's a form, the equation will be of the form of quadratic equation. Right. Finally, we have come to the last part of the video, which is hypothesis writing. So what is your hypothesis? Writing a proper hypothesis, you need to explain what you expect it to happen. Okay, what will happen, and you should be clear and understandable, and it should be testable, it should be feasible one. Don't mention anything else what you think. It should be measurable one. Okay, so the values that you put across should be a measurable one, should contain an independent variable and also a dependent variable. So all these 5 parts should be present in a proper hypothesis. So meaning of proportionality, we already seen this. I'll just skip this slide. So examples of hypothesis: if the length of a pendulum is increasing, then the period of the simple pendulum's swing will also increase. So let me ask you one question. Which one is your independent variable? Which one is your dependent variable? So this will be your independent variable, right? Length of the pendulum is increasing. That means it's in your hand. You can have 5 centimeters, 6 centimeters, 7 centimeters. You can keep on increasing like this, right? So this is your independent variable, okay, which is a measurable one. And the period of the simple pendulum swing will also increase. This will be your dependent variable, which means once you conduct your experiment, you will get some values. This will be your dependent variable. Similarly, let us look at this. If the angle of projection of a projectile is increased, if the angle of projection, okay, so this is your projectile motion. If the angle, so you're saying you are going to increase the angle of projection, which means what? Initially you are throwing it like this, then you are throwing it like this, then you are throwing it like this, then you are throwing it like this, right? This angle is being changed manually and it is in your hand. So this will become your independent variable. Then the range of the projectile will increase. Range of the projectile will increase, right? It can increase like this, okay? Up to an angle of 45 degrees. See, now you are putting the condition here. It is not universal. It happens only for 45 degrees, after which the range will decrease. Which statement does it tell you? It tells you this one. It says, be clear and understandable. Okay, don't mention whatever you like. Okay, mention it clearly. So we have to put that also there. Then if the resistance in the circuit is increased, which is this, is your independent variable, while keeping the voltage constant, you are very clear. See, this is true only when you keep the voltage constant. When you change the voltages, change the battery, when you keep on changing the knobs over there, then definitely the current in the circuit will decrease. When the current in the circuit will decrease if resistance is increasing, right? So opposition to the flow of current is increasing, voltage is kept constant, the current will decrease, right? You have mentioned it correctly. Then if the force applied to a string is increased, once again, this is your independent variable, the extension of the proposed string will also increase proportionally. Now what you have mentioned, you have put a relationship also, right? You say that this force is proportional to x over here. Okay, you put this also here up to the elastic limit of the spring. Okay, proportionally. Why do I highlight this one? It means that if you plot a graph of f versus x, you will get a straight line passing through the origin. So that is where proportionality should come. See, in none of these cases, okay, here also I said will also increase. Did I ever say it will increase proportionality? No. Okay, so therefore, so if you plot a graph of the length of a pendulum, length of the pendulum and the pendulum's swing, okay, as pendulum swing over here, you will not get, okay, something like a straight line passing through the origin. You might get, okay, some other line, okay, and you might get a line, you might get a curve also here. Anything can happen. Okay, I did not say it is linear. Okay, so do not unnecessarily assume, okay, when you have a statement like this, do not necessarily assume that it will always be a straight line. Okay, so I think with this we come to an end of 5 lectures which are very much relevant for data analysis. Thank you one and all. Please share, like and subscribe to my channel for more such updates. And if you want any specific videos related to IB curriculum, do let me know. I would be happy to make such videos. Thank you. Thank you once again.